Go back. Now, that's the first output. I'm now going to look at the second output. The second output came on. The second output followed this type of pattern. When there were no pumps running, it would be off. Both the green lights would be off. When one of the pumps was running, the first of the green lights would be off and the second one would be on. So when one of the pumps was running, it would follow this pattern. So the second output would be switched on. When two of the pumps were running, it would be in this pattern. So let me just draw in the green lamps so it's absolutely clear. So this means both green lamps off. This means that lamp off, this one on. This means this lamp on, that lamp off, and this means both of the green lamps on. So just considering this green lamp here, turning on and off that green lamp, right? Now when you look at it, that green lamp switches on in that case when one of the pumps is running. It also switches on in that case when three of the pumps are running. So I could write an English sentence that says the green lamp comes on, the second output I mean, comes on when one of the pumps or three of the pumps. And the big important word there is or. Or means two switches wired in parallel. So we have two switches. One of the switches is called one of the pumps, and the second switch is called three of the pumps. And the circuit we end up with is those two switches wired in parallel. I have two switches called one of the pumps, and one switch called one of the pumps, and one switch called three of the pumps. And when either one of those comes on, the output will come on. My problem is, of course, I don't have an input called one of the pumps, and I don't have an input called three of the pumps. So what I'm going to have to do is I'm going to have to work my way further into the program. I'm now going to have to create a couple of relays which are called one of the pumps and three of the pumps. This is what I end up with. I have an internal relay called three of the pumps and an internal relay called one of the pumps. The way I made these two relays, the way I did the circuit for these two relays is, I said three of the pumps comes on when, when pump X and pump Y and pump Z. Of course, the important words there, pump X is a switch. I'm picking that up off R1. Pump Y is a switch. That's the pump Y CT. Pump Z is a switch, the pump Z CT. And that tells me to wire those three things in series. The other circuit here, that one and only one of the pumps is running. The English sentence I get for one and only one of the pumps is running is pump, I'm just going to write pump X is on, and pump Y is off, and pump Z is off. To get the pump Y is off, I pick up a normally closed contact off the CT. To get the pump Z is off, I pick up a normally closed contact off the CT. So that's the first circumstance of one and only one pump, there are two other options. The other option is or pump X is off and pump Y is on and pump Z is off. Now there's two important words that just popped up there. Firstly, I've got these ANDs. The ANDs are telling me that I'm wiring in series. So here, I'm wiring in series. The second important word is this OR. The OR tells me that all of the stuff on the top line is in parallel to all of the stuff in the bottom line. OR means series switches in parallel, and means switches in series. If you can write it out in English, find the ANDs, find the ORs, you can wire it. Now the bottom line, the last line, is there's a third possibility. The third possibility is OR, pump X is off, and pump Y is off, and pump Z is on. That's the third possibility. Once again, we've got an OR. Once again, we've got a series of switches in series. The OR tells us that we've got a parallel line and the switches are in series. So this will tell us that there is one and only one of the pumps is running. Okay, so the second output, the circuit looks like this, where this is three of the pumps. This is one of the pumps, and this tells me that the output comes on either when three of the pumps or one of the pumps is running. And remembering back to, what we were initially trying to do, that would be correct. This will work. If the English sentence works, this works. The output comes on when one of the pumps or three of the pumps. One of the pumps or three of the pumps. So that's how we do relay logic programming. We write out an English sentence, we look for AND tells us we got things in series. We look for OR tells us we have things in parallel. And we wire it up in series or parallel. Now, we have the third output. The third output concerns itself with the other output light. Now the way this looked again, we had two lights off. That's one of the lights on. This is the other one of the lights on. And when both of the lights are on, that means three of the pumps is running. So looking at this line here, this light here, which is this light here, that light comes on. My English sentence I've got for that is, that comes on when two or three of the pumps are running. So this comes on when two or three of the pumps are running. So what we're going to try and do now is, this is the circuit you've got so far. What I've got is, I've got that third output comes on when two or three of the pumps is running. What's missing is a little bit of circuit which is going to give me a relay. I need to generate a relay, and that relay will be two of the pumps is running. Now what I'm going to do is, I've never tried this before, but what I'm going to do is, I'm going to give you 15 minutes to quickly sketch that circuit up. If you look in the book, there is space to do this circuit around about page 306, 307. There is some space in the book for you to sketch that circuit in. So I'm going to give you 15 minutes. I'm going to stop the recording and I'll come back in 15 minutes to give you a chance. I'll see you just in a little while, okay? Done really well, and I'm sure you got more or less the same circuit as I did. Let me just go back to that quickly. I think you probably all got the same circuit as me. You're going to have a chance in a moment to jot down this circuit. What I was just talking about, before I noticed I'd forgotten to turn my microphone on, was that there is a possibility of an alternate circuit. Because looking at this third output, this output here, there's a possibility of an alternate sentence. Can you see another sentence that would describe when this light comes on? Anybody see another sentence? Yeah, another way of looking at it would be when there's two or more pumps running. So the circuit I came up with looks like this, and actually a simpler circuit would be just whenever there's two of the pumps running. So a simpler circuit would be would not have the other things in it. So a simpler alternative that some of you may have come up with would not have that, or that, or that in it. So some of you may have come up with the alternate circuit that looks like this. Now, either one of those circuits is correct, because either one of the sentences is correct, so either one of the circuits is correct. So there's often more than one solution. Now, what I would suggest is that you make a note of this circuit if you haven't already, because one of the exercises I ask you to do is to take this circuit, which is relay logic, and convert it into PLC language. The PLC language we're going to use is ladder logic. Ladder logic is simply a copy of relay logic, but using slightly different symbols. So for instance, in ladder logic, the first line would be written, let me just get rid of that. Instead of writing a switch like this, in ladder logic we write a switch like this. And instead of writing a normally closed contact like this, we write a normally closed contact like this. So that if we were to translate this relay logic circuit into a ladder logic circuit, all we have to do is change the way the switches look. So the first line looks like this. Relays, instead of writing a relay like this, as you do in relay logic, we write a relay like this. Looks pretty well the same. So the first line becomes this.